Hello, I'm Daniel Flory. I'm the General Manager for Altec Industries in Elizabethtown, Kentucky. I'm part of our management team to lead our campus through building utility communication trucks. Today has been very enjoyable to see the students with their hands-on exercises, and the engagement from the teachers to the students, and also the teamwork from the students working together to solve problems. It's exciting to see those skills being taught and the ingenuity of our students in solving problems. The We Build It Better is an opportunity for us to invest in our community more than just being an employer. We want to be engaged for the success of students with this hands-on training for whatever future endeavors they have. Altec in this area, we've been here since 1998. We've been able to be a long-term employer for our area. We have a successful career path for many different associates, and helps people live in areas they want to live and be with their families and support their families. I'm just really excited about our teachers and the engagement they have with the students and the passion that we saw today and teaching the curriculum and getting students ready for whatever future career path they want to take. It's been very exciting to see today. We had hands-on training for the teachers at Altec Industries this summer. A great time to spend some dedicated focus with them, and now seeing that put into action in the classroom is very rewarding.
You're going to actively learn how to use a drawing software today, and then your business principle is judgment and decision making. So your judgment and decision making comes from all the designing you've done of your backpack tag. So you have your technical drawing in front of you, and we're going to put labels on that today. You have your prototype that you are attempting to create out of some very stubborn clay, and then you're going to be making design choices when you actually use the CAD software as well. Okay? So your clock in today is, what do you know about 3D printers and how do they work? Do any of you know anything? Okay, what do you think you know? John, go ahead.
3D printers use a string of plastic and melts it to print out a design.
Yeah, nailed it. Okay, yes, they basically use a string of plastic and melt it to print out a design. So like when we were making the airplanes in kit 1, okay, you used hot glue gun. It's like a similar type of concept. It's basically melting something. But that's what the 3D printers are going to use. We will use a 3D printer to print off your backpack tag once you are done completing your design. Essentially, by the time that you are finished with all of your designing, your prototyping, and our cost analysis and all of the stuff in the data sheet, okay, then you are going to physically be able to print with one of those your thing and take it home with you and show them what you did. Okay, so I know that we're having some technical difficulties with Tinkercad. So on the next slide, so you have your clock in done. On the next slide, it gives you the link to go to. So go ahead and click on that and see if it lets you log in. I'm going to show you on the screen essentially how you're going to set yours up so that when you get there, you can. So we have talked about meeting schematics and things before. Does anyone remember when we talked about people needing to draw those so they could be submitted for a patent? Okay, if we're trying to get a patent approved, we would have to make some sort of like drawing and schematic for that. Okay, so in the past, it would be hand drawn, correct, by someone who was amazing and had a lot of measurement success and all of those things. Okay, but now, because of technology, we have computer-aided design. It's the use of computer software that supports the design process by helping to create, modify, analyze, and enhance a design. CAD is preferred because it takes less time to create and is easier to edit. As you found out yesterday, okay, how difficult it can be to create something extremely simple with clay. So imagine trying to create multiple prototypes every time your business or company wanted to offer anything new to a customer, and it had to be done by hand. Okay, you would have whole crews of people just dedicated to that. Okay, versus now we can do this, and I'm going to show you how to set up your little thing. So when you get into Tinkercad, you need to click where it says to create a design. Okay, so it might be on the left side of the screen. It might be just, yes, it says create design, and you want a 3D design. Okay, so plus sign says create. You are going to set this plane up so that you can modify it the way we need to. Okay, well, this is your work plane. Okay, this is where you're going to create all of any kind of design that you want for now, for the future. Just to play around with it today is really what your goal is to learn the features of it. So I've assigned you some tutorials to do in it here once we're finished with the stuff that we started on from yesterday. So it always gives you some sort of wacky name in the top corner. Okay, so I want you to just rename your file up there in the top corner. Like this one says Glorious Tunalo Albar. Okay, yours says something equally weird. Just go ahead and rename it and just put like exploring or tutorials or practice. Okay, something like that. we'll make a whole new file for the next time when it's supposed to be for our actual backpack tag. All right, and then we need to change the setup. So down here in the corner, okay, where that arrow is pointing, you want to go ahead and click on that menu. And we want to change our measurement from millimeters to inches. We want to change our units from millimeters to inches. So there's a little drop-down box. And then once you've done that, you can hit save. Next thing is we're going to change this little scale down here in this drop-down. Okay, we want to change it to 1/8 of an inch. You have your plane set up the way it needs to be set up, and now you can modify that. You can drag and drop those shapes. You can do all kinds of things with it to just play around with today. Okay, I have also assigned you some tutorials in it. When you go into a workspace from here on out, make sure that you change those exact same settings every time. Okay, so we went to settings, the little box in the bottom corner, and then we changed the snap grid to 1/8. Okay, so every time that you want to mess with one for this class and our purposes, that's the settings that you need to have set up for it. Here's what we're going to do for the rest of the class period. I know that a lot of people need to finish their prototype making from yesterday, which is fine. And I know that we need to add some things to our technical drawings. Okay, so have your blueprint drawing, your technical drawing out in front of you because I'm going to show you what we're going to add to that. Your drawings are nice little basic places for people to start, but if you remember that little schematics that we showed on the patents that we did several weeks ago, or that schematic that was there for that CAD drawing, it's extremely detailed, okay? When you look at yours, would you consider it extremely detailed? Probably not, okay? So we're gonna add some labels, because if I were to hand this off to somebody, they're supposed to be able to recreate what you want from that. And right now, based on the way that they look from how we started them yesterday, that's not possible. Just like when we're doing like scientific method type things, if I don't write up the instructions so detailed that people can recreate it, like when we talked about like making recipes, you're not gonna be able to pull that thing off. Okay, so these are some things that we need to add. Your actual dimensions need to be on there, okay, actual dimensions. And I just put length and width, because for everyone that's different, because you have your own data spreadsheet that we pulled that information from. So that's why I had you get your data spreadsheet pulled up, okay? The drawing scale, our technical drawing is we did a 2:1. So your actual dimensions might be 2 and 4, okay, but then your technical drawing is supposed to be a blown up version of that. So the drawing scale is 2:1. When you get the chance to actually print it, the way it gets designed, and whether you inset the lettering on your tag or if you raise it up, that's going to change the way it prints. If you inset the lettering, it's going to cut the letters out to be able to see through it, okay? If you raise it, it'll make it more of a 3D image, so it's like coming out at you, and you could actually feel it. So you're going to need to make that sign. So that goes back to the judgment and decision making. Okay, inset or raise. Just put that off to the side and like have it pointing to your lettering or whatever's on there. Like Addison made her yesterday, and hers is obviously raised up. Okay, you can look at Addison's later, and she actually made her letters come up off of it. A lot of you like took your pencil and you kind of engraved whatever you're going to have in there. That means you want the inset because you are punching that out essentially. Then the tag inset distance is 3/8 of an inch. You need to have that on there. And some of you were trying to make the tag when you were making your prototype. You don't need to do that, okay, because you're not going to get that material. I have it for you. And some of you actually went ahead and made the hole in your prototype, which is excellent. Some of you did not. Okay, so make sure it's reflected on your drawing and make sure it's reflected in your prototype. And the key ring hole diameter is 1/4 of an inch. Okay, so these are the labels that need to be on your technical drawing. I have made a to-do list because I know we're all kind of in different places. First, finish the technical drawing with the labels that I just went over. Okay, some of you need to finish your clay prototype because as we found out yesterday, the clay was not friendly. Measure clay used with calipers to calculate volume. So once you have the prototype done the way you think it needs to be done, you're going to have to stare at it for 30 seconds and tell it how much you love it, but then you're going to have to crumple it up. Okay, because we need to make it into a sphere shape, and we're going to use the calipers from the tool cart to figure out its volume. And we're going to put that number into the formula so we can figure out how many cubic inches of material we are actually using. Okay, once we do that, that number goes in your materials cost tab on your spreadsheet. And I'll pull that up for you here in a second so we can see where that is. Okay, make sure yesterday's clock out is complete, and then after that, you're finished and the tutorial or the technical drawing is turned in and all of this stuff is done, then you have the rest of the time to mess with Tinkercad, okay, and learn how to use it, familiarize yourself with it, because tomorrow we're going to design your backpack tag in it, okay? It'll be a lot easier if you know how to do some things. Okay, so I'm gonna leave this up here. Okay, go ahead and start your labeling if you haven't already.
My favorite part of class is probably building the things. We are working on making bag and luggage tags for the 3D printers. I like the activities about the class, like that in the class we do activities instead of being on computer all day. So.
Right now, my first period class is We Build It Better. Basically, we design stuff, build stuff, and also learn skills that could be really helpful in the future of a generation or a world. We've worked on using calipers, rulers, measuring tapes, and right now we're working on Tinkercad. It's better than a regular class in that you get to have hands-on experience, which is really good for you. You get to use valuable skills and tools that could help you in the future.
In my opinion, it's just giving us real-world experience about what, depending on what we want to go into when we're older, about what we're going to really see and to understand it better. I think the real-world experience definitely helps because I do like STEM in that area too. I think definitely the learning how marketing and those kinds of things help definitely in the class. My favorite thing we've done is the backpack tags that we're doing now. We started around 2 days ago, and Miss Lynette gave us a prompt, and then the next day we got into pairs. We did a spreadsheet, and we looked on other websites to find similar ideas to what we wanted to do. And then we split up from our pairs, and yesterday we started making prototypes out of clay of the backpack tag we want to make, and then tomorrow we're going to use Tinkercad and we're going to 3D print it.
Every 8th grader will get We Build It Better in 2 trimesters, and it's newer to our school, and we're loving it so far. It's really nice. It's teaching you a lot that you didn't get to learn before. Mainly the hands-on stuff, because in a lot of classes you don't get to do that. I want to be an engineer. I think it's going to help me by teaching me how to work together, safety precautions, and more hands-on stuff so you know what you're doing in the future. We made a little model airplane out of foam, toothpicks, and glue. And I thought that was really cool because it's teaching you how to create stuff and how to do stuff even though you don't have the right materials. The project that we're working on right now is making a tag, so we're making it out of 3D printed. We're using this website called Tinkercad to help us make it, and we made a design so when we use Tinkercad we know what to design on there and how to use it. There's no other class like We Build It Better. We Build It Better is its own little thing, and it helps a lot of people. I would tell other students that you're going to have a lot of fun in there because of how hands-on you are, but everyone's really nice, and you get to hang out with other people and learn how teamwork works. I would like to build buildings and stuff. I think that would be pretty cool, especially building homeless shelters and vets and stuff, because it helps a lot of people out.
Zero. There you go. All right.
Hey y'all, hey, I talked about this yesterday, I didn't mention it this morning, I forgot to. Remember, the 2 types of calipers are going to be dial and digital, right?
Digital.
Dial and digital. Anybody remember which one's more accurate?
Dial.
That was perfect. You said which ones were there? You're trying to think. Perfect.
This digital or dial is way more precise.
On page 31, so just highlight the right answer for me. You got thousandths of an inch up to 6 inches, right? All right, there you go. All right. Okay. All right, guys. So we have a few videos here to talk about how to read your dial caliper, okay? And then I'll be going around the tables, making sure you guys understand, all right?
A caliper, or set of calipers, is a tool used to measure the distance between opposite sides of an object, usually with much more precision than something like a ruler. You can find them in many fields, including woodworking, metalworking, medicine, mechanical engineering, and many other sciences. So while they're not related to electronics exactly, I find myself reaching for my trusty calipers all the time to do things like measure the distance between leads on an electronic component when it's not listed or I can't find the data sheet. The first set of calipers discovered date back to the 6th century BCE, and they were tools used often by the ancient Greeks and Romans to make precise measurements. Bronze sliding calipers from the Han Dynasty were also unearthed dating back to the year 9 CE. Most modern slide calipers work on the same basic principle. There is a fixed main scale attached to one or more sets of jaws and a slider that moves linearly across the main scale. The slider has the opposing set of jaws which move to measure the object in question. You can read the distance measured by looking at how far the slider has moved on the main scale. Many calipers have a thumb wheel that gives you more precise control over how the slider moves, and most calipers include a lock screw you can tighten to prevent the slider from moving to hold the last measurement taken. This can be helpful if you need to move the calipers away from the object to read the scale, or if you want to compare the dimensions of two different objects without writing down the measurements.
Here's what I want you guys to do real quick, all right? I want you guys to take your dial calipers and go ahead and measure the edge of the table, all right, where you're sitting. And I want to see if any of y'all can figure out what that measurement is. We're going to go over here in a minute, but I want to see if any of y'all can figure it out. Anybody else have some measurements? Aaliyah, what measurement did you get? Figured out? 1.1. All right, what was 1,000? Going up to 1,000 for the minute, right? All right, guys. So now that you got a little hands-on with that, we're going to go ahead and shut the lights off again, and I want you guys to pay attention this time pay attention to him because he's going to talk about how to read your dial. All right?
Dial calipers require a bit more effort to read, and they usually only come in either imperial or metric. To read them, find the largest measurement on the main scale visible to the left of the slider. In this case, it's 1.6 inches. Then, read the dial, which is 68 in this example. Since the dial says it's an increment of 1/1000th of an inch, we know it's 0.068 inches. Add the coarse and fine measurements together, and you get 1.668 inches.
The reason I wanted to be in the We Build It Better class is because I've always had an interest in engineering. I took an engineering class in the 6th grade, and I've always been wanting to do something like mechanical engineering or computer engineering since I took that class, and I think it's going to be a great job, and I'm very interested in it. So the experiences I have had in the classes, like the previous engineering class and We Build It Better, is building things like model houses, model cars, catapults, and in there I built a model Wright Brothers airplane and a robot. So I would like to do something more like mechanical because it's fun to build things and create new things and solve problems. I feel that We Build It Better can give me a good foundation because it's basically teaching me the basics of engineering. So if I would to major in engineering, I'm going to be a step ahead of the rest. I'm going to be near the top of my class, and I'm going to have a better lead into it and just be more successful in general. In the future, if I were to have my name imprinted on anything, it would be something that could help improve people's lives, something to make something easier, or something that improves something to make it better, and just something that helps people in general and to stop causing problems. This class helps me with critical thinking skills because it helps teach me how to solve problems. Like it has taught me the engineering design process and the scientific process of how to do things and how to solve problems and think of new solutions. We Build It Better has helped me improve my confidence in other classes because it just helps you in problem-solving skills in general. And also, engineering classes like We Build It Better are a lot of fun and help you lay off stress about other classes. Like I have not had a homework assignment yet in this class, and all I've done is stuff that I think is fun.
Joining We Build It Better helped me. Well, I got asked to join by Mr. White. I've had him for 3 years. Well, this is my 3rd year. I had him for 2 years for career choices, but I wanted to do We Build It Better because it's fun, and I thought I would have like more out of stress. I wouldn't have so much stress on other classes. It's fun to have. We did a lot of projects so far. One of my favorite things that I've enjoyed in this class, We Build It Better, is building projects. I love speaking in front of people, so having speaking, it helps me in other classes with projects. And building stuff, we built like the Wright Brothers airplane, we built robots, and it's just really fun to have and like not have a lot of stress on other classes. So this is like a free class and learning with your teammates and helping them with our communication. This helps me with my foundation in growing and having a lead in front of everybody else is by like, let's say in college or like the 3D printer. It helps, we're gonna 3D print like the hearts for because I wanna be a pediatrician, and with the hearts so you can see, so it'll help you be way more successful in the future by having like all the techniques and stuff that I need. When I was offered this opportunity by Mr. White, I was just like, at first I was just like, I don't really know if I wanted to do this, but I was like, okay, I'll give it a try. Just like Ms. Sims' class for agriculture, I was like, okay, I'll give that a try too. So this helps me by like way more successful in communication. I love it so much. I'm glad I got offered this. It's like a free class and it helps like learn and more stuff. And like, let's say it helps in math, like today it helps math like decimals and fractions.
So our toolbox meeting today, our goals is to explain the product design process that is used to solve real world problems, explain the criteria and constraints of the backpack problem, because we do have a backpack problem you're going to learn about here in just a moment. Compare the waterfall and agile methods of producing products. And our key terms today that are up on our word wall over here, this is our new word wall for Kit 3. We're going to learn what agile and waterfall mean. Our workforce skill is complex problem solving. So we've got to think about how we're going to use those steps in that product design process to come to a solution. And then our business principle is, are we going to use the agile or the waterfall methodology to be able to solve this problem and create this product? So we are going to bring in, we have a situation, Miss Michelle does. Miss Michelle, could you come in and tell them what problem we are having?
Guys, I'm frustrated. Like, I can't even talk about it. You know how small my room is over there? Yeah. So everybody, they come in, they have their book bags, and they just throw them right there in the back of the room. So then at the end of class, they grab their book bags and leave. But some people leave their book bags. Well, I don't know whose book bags they are. I can't go through your stuff. So I'm trying to figure out whose book bags are back there, and I don't know what to do.
I have the same problem in my classroom. Students bring things in, they leave them, and we're not able to find them or locate the owner of those backpacks. So what is it that we can do to help you solve that problem?
Well, I think I need something with their names on it. So I was thinking maybe a luggage tag, but we can't have just boring luggage tags. So I'd like a big luggage tag with maybe a heavy fastener to keep it, because you know we don't want them ripping. big heavy fastener with their first and last name be able to fit on it, so I can see it from the back of the room.
Well, I've got some good news for you today.
Hope so.
You have a whole classroom of inventors and innovators here. Are you all willing to help Miss Michelle?
Yes.
Okay. And I'm assuming you probably want this within a certain price range.
Yeah, so I was gonna look on Amazon because I don't want to be spending too much money on it. So I was gonna look on Amazon, but if you all can make it cheaper than Amazon, that would be great.
Wonderful. Well, we're going to see what we can come up with for you, Miss Michelle. Thank you for stopping
Look
in and
forward to
telling
it.
us.
Thanks,
All
guys.
right, so we got some backpack tags that we need to get to her to help solve her problem in identifying who these belong to, because that's very important. Y'all remember the Wright brothers?
Yes.
Right? Well, we're going to watch a video and see from them how they used the process and the product design process in particular to solve some of their problems in creating their airplane.
You know, we can always say that we build planes the right way.
Wilbur, we also built planes the wrong way.
No, like right. W-R-I-G-H-T. The right way means we had our own process.
Listen, let's trim some of the fat off of our previous process so we don't have to wait 2 years to get another plane into play.
What process are we following in here, Ava? Their product design process. So that's what the Wright brothers were explaining to you. There is a linear process, and we're going to talk about the difference between agile and waterfall. So this process, when we look at the product design process, which looks a lot like the engineering process, it looks a lot like the scientific method process, except when you get down to this area, we're building and manufacturing this product. And we're not just doing that, but we're shipping it. Then we're going to look and see if we had a success or failure with that product. And then we're going to take it one step further. Okay, with scientific method, you're always sharing your results, but we also want to determine what type of environmental impact that has had, our product has had out there. So we're going to follow the product design process. Our first step, when Miss Michelle came in, she said, what was our understanding the problem? What is the problem that Miss Michelle is having in particular? Brianna.
She's finding bags that are being left in her room and she doesn't know whose they are.
Finding bags left in her room, not sure who they are. That is the big first step. What do we need from, what is our customer asking us for? Okay, so we got to identify what does the customer want.
Name tags with accessible hand grabs, that way you can pick it up easily, and that way, and it has to be sturdy, that way it doesn't just break off.
Durable.
And she's also asking for a cheaper cost than Amazon, that way it's more accessible to teachers and everyone, that way it's not as expensive.
So what is she giving us? When she tells us all of those things, what are those called? Criteria and? Constraints. So we're looking at exactly what is this customer needing from us, and then there's going to be particular constraints. So the big first thing that we need to understand from our customer, and Miss Michelle came in and did a great job explaining to you, she needs to be able to see those backpack tags clearly from about 6 feet away. She wants them to be washable, durable, must have this part she probably didn't get into, but this is what we're going to add to part of your criteria, a 1/4 inch diameter key ring hole. The key ring hole also cannot be inset farther than 3/8 of an inch from the outside edge. So currently I'm 3D printing a sample tag over there on the 3D printer just to kind of give you an idea of what you're going to be printing. You're going to be designing your own tag. And we're not only going to look at this and sketch it out on paper, we're going to follow those methodologies that I just mentioned, and we're going to talk about those a little bit further. But you're going to create this as a clay model, which is a good visual. Then you're going to take it from a clay model and you're going to 3D print it after you use Tinkerpad. Now some of our constraints, they can't be any larger than a 3x5 inch index card, so it can be less than that, can't be larger than that. The reason for that, if you look at the platforms on those 3D printers, the platforms are going to constrain you as far as size. They're not very large. You can kind of go up tall, but as far as the width and the length of it, you're going to be constrained to that. Thickness should range between the thickness of a sheet of paper and 1/8 of an inch. Must be a combination of at least 2 geometric shapes. What 2 shapes do you all see that are right here? Let's see. No. Rectangle. What else do we see, Prim? Yeah, like I said, like I have semicircle right there. So that's 2 geometric shapes that are shown on the board for you. And it has to be produced within this time frame. What does this time frame tell you?
It's like what is expected in like this class period, like how long.
That's what I was looking for, exactly. It's what's expected that we can do inside this class period, so 30 to 60 minutes, very good. Now I want to talk to you about our 2 design methodologies. We have a waterfall methodology, which is linear, which means you're going to start from here and move downward through your product as far as when you're designing it and testing it. That would be what a waterfall methodology is. So it's used when your criteria and constraints are known. This is the methodology you're going to choose if you know those 2 things, okay? It follows linear order from top to bottom. It's typically used in the manufacturing industry. So you're going to see that in a lot of mass production and a lot of your lines where people are working on factory lines. They're going to be using linear. Starts at this end and it moves, and there's something added to it all the way down. We also have the agile methodology. This one's a little bit different, different type of customer, okay? I'm going to give you an example. My mom needed some handrails made for her house. So I went to a welding teacher and I said, can you make some handrails? Sure, I can do that. Here's what I would like for you to produce for me. No problem. He sketched it up. I looked at it and I said, I think I'd rather have this dimension rather than this. So we started here. We're kind of moving around our product design process. Then we had to go backwards and redesign and talk about another way. With this type of process, you're mobile and you can move and stop at any point and say, whoo, before I ship this, I need to go back and talk to my customer again because I don't want to ship out the wrong thing. Because you don't want to upset your customers, do you? You want to keep them for a long time. So this process works for different types of products that you might be putting out there. For our product, for our backpack tags, which process do you think we're going to use? Which methodology? What do you think, Riker? Waterfall. Why do you think we're going to use waterfall? We know all the criteria and constraints. So we know that information, so that tells us real quickly, hey, this is the best method for us to be able to go through and produce this product.
I got into the We Build It Better program through a teacher invitation, and it's really fun. What I enjoy most about the WBIB program are the hands-on projects and the critical thinking that we have to do with the trial and error. We have learned how to use the tools that are in the Snap-on kit, and we've learned to measure things. I'm really looking forward to the welding because I like making things just in my house, and that would be a really fun way to make stuff. This program helps me be an independent thinker and learner because I have to think of ways to solve problems, but then also helps me with teamwork because I have to learn how to work better with people and divide up the work.
This class was different from my other classes, mainly because we were working with different tools, and they were talking more about more cooperation and teamwork rather than other ones. Also, they provided different ways of learning. For example, if you were more of an audible or audio listener or hands-on, or you were more like a writer and stuff, different things like that, they provided all of those for you, and so it was really compatible with lots of students. The WBIB program will help me with my future career because I want to work in as a real estate agent, but also that may change. But this has definitely helped me because it's helped me work better and cooperate more with team members, because lots of times we have to do teamwork jobs or projects, and it's really helped me cooperate and also show me how to take the lead or also listen directions better. Another thing is that you also get to do more
you have to work under time constraints, and that's definitely one thing that I think will help me, like, regardless of whatever job I choose to do, because every job will have a time period where you need to get something done, and this has definitely helped me with that. It is a lot, like, definitely level playing field, because there's nothing telling you that you can't do a certain thing just because of another thing, because, you know, it's all mainly based on how you work well with other team members and your thinking process and how well you can come up with things. It has nothing to do with gender or like all those different like constraints, I guess, because there are different things like men and women can do, but we're all pretty equal, and this class definitely does not have any of those constraints. I really enjoy this class. Like, I look forward to everything we do in this class. Like, whenever I come to school, I look forward to this class just in general, because you get to do more different, you get to do different projects, get to work with all kinds of different people, and it's also like helped me talk to more people that I didn't even like really talk to. And it's just one of those classes that you just really look forward to. But if I had a project I would choose, it would definitely be the welding one, because I think that's pretty cool.
Well, it's more like job involved. So like you can obviously have a job that involves all this stuff, and it's more hands-on than everything else. Well, we have different constraints, so we obviously have the different measurements that we have to use. So we have to use all the toolbox, the tools from the Snap-on toolbox, and we have to just get it in a certain amount of time for the teacher. I'm going to do a civil engineering, and it'll help me in this class because civil engineering is very hands-on and it involves a lot of like building and stuff. Being a civil engineer, one of the things that I would love to see my name on is probably a big building in a very large, busy city. 3 things I enjoy about this class is probably a lot of hands-on stuff, the very critical thinking, and teamwork.
We are going to work on making interchangeable parts today. Everybody is going to get a container of Play-Doh, okay? Go ahead and everybody grab one. So what we're going to do today is you are going to have to create 3 identical shapes by hand. Okay? We can't use it. You use what you got right there on that table in front of you. You need to create, but here's the thing, I see some of y'all like, yeah, I'm going to make this circle. Let me give you your constraints. This group is making a pentagon. If you're green, you're making this pentagon, 5-sided shape. My center table, y'all are the lucky stars. And my rhombuses are the white table. If you got white Play-Doh, you're making a rhombus. Okay? You are going to have 2 minutes to create 3 identical shapes. Remember, to be an interchangeable part, it has to be the same size, the same shape, and the same thickness. So you can't have one that's this thick and one that's this thick, because that won't be interchangeable. Okay? You can't have one that's this big and one that's this big, because it won't be interchangeable. All right? So you're going to have 2 minutes to make 3 of your given shape. Are you ready? Go. Leftover Play-Doh. You don't have to use all of it. You just have to have 3 the same size. Ooh. Just me and Aiden? Scarlett. Oh, I see you over there, Scarlett. Are they all the same size? Here are mine. Here are my stars. What challenges did we encounter? I want you to talk to your table. Turn and talk to the person next to you. What challenges did you encounter? I walked around, I heard many different reasons, okay? Samantha, what did you hear at your table?
The time.
The time. How many people had issues with the time? How many people had issues with the amount of Play-Doh you had? Yeah, that was another one. Was it difficult to make them identical? Yes. Here's mine. Yeah, it was. Okay. So what is a tool that would make it easier? I saw somebody over here using their fingernail. What's something that would have made it easier? Something to cut it with. Okay. So roll your Play-Doh in a ball, and I'm going to give you something to cut it with. And we're going to do it again. Okay. So I'm going to give you, Aiden asked for something to cut it with. That's what he's going to get. Okay, so I was really nice and I gave you a ruler, so that means you should be more efficient. You now have to make 4 shapes in the same amount of time. Okay, you have the Play-Doh, you have a ruler, you have the same shape, and you have to make 4 of these shapes in 2 minutes. Okay? Everybody ready? Yes. Yeah. Hands up. How many of you were able to make 4 shapes? Okay, I cannot raise my hand for that. Were all your shapes the same size? Okay, y'all remember what my stars look like without the ruler? Look what happened when I used the ruler. Oh, I don't know. I think it worse. I have no idea how my shapes got worse, but they did. So did the ruler help you? Yes. If the ruler helped you, give me a thumbs up.
Is this right?
If y'all think the ruler helped me, give me a thumbs up. All right. What challenges did you face? Time. Again, time. With me, I faced trying to figure out how to get those inside angles. Okay, so I made, on this one, I made 4, 5 triangles and then shoved some Play-Doh in the middle, and then I tried to like copy it, lay this one on top. It didn't work very well. Okay, would my customer be happy with these interchangeable parts? No. Would you be happy if you received this? No. No. If you needed it to be an exact star to go into, yeah, it wouldn't work. Okay? So, what would make you more successful? Time. Okay, what else would make you more successful? If I said you couldn't have any more time because time is money. Okay? We've talked about lean manufacturing and we've talked about how time is money, right? The more time you spend on something, the more money it's costing. It's going to cost the company more money. So if I can't give you more time, what can I give you? More Play-Doh. More Play-Doh? What else? But more Play-Doh is going to cost me money, right? Like a what? A square? A cookie cutter? I can give you a cookie cutter. Okay.
I think I made my
Where have these been this whole time? Okay, so if you're a star, you now have the star cookie cutter. How many people think that they're going to be precise now that they have a star cookie cutter? Now that you have a pentagon. Do what? Oh, Kennedy brought up a good point. What was that, Kennedy?
You have to make sure the thickness is still the same.
You have to make sure the thickness is the same, because what happens if one of yours is super thick and the other one is super thin? Are they interchangeable? No. Oh, I'm being stingy with y'all. Here you go. Okay, so we're going to do the same process again, but what happened the last time I gave you a tool? I added more things, right? I had more shapes you got to cut out. So what do you think's getting ready to happen? 5 shapes. 5 shapes. And I'm not changing the time because time is money, right? I can't give you any more Play-Doh because that's giving you more materials, and that's going to cost my company more money. Okay, so you're not getting any more time, and you're not getting any more Play-Doh because I can't give you those resources. But I can give you the tools you need to be successful. Round 3. You have the same amount of Play-Doh. You have 5 shapes. And you have a stamping tool. Okay? So let's see if we can stamp 5 shapes in our allotted 2 minutes. Elijah, was it harder or easier than round 1 and 2? Why was it easier? You had the cookie cutter, you had that stamping tool, right? All right, so was it faster?
Yeah.
So if I was a manufacturer and I had given you that tool to start with, would you have been more productive? Okay. Were the shapes more consistent? Because you guys all saw my stars at the beginning. They were a little, and then they got worse, okay? But if I had had the star stamper, they would have been like this, okay? Are they the same thickness? I stamped out some in my last class, and they are the same thickness, they're the same size. Now, I did not get out the caliper, but we could get out the caliper and measure and see if they were the exact same thickness, okay? So what would happen if you were on an assembly line and you were asked to do the same thing? How do you think you can make the assembly line work? Automated. What do you think that means? Tell them what you mean by automated. Make it go by itself. Okay, well, we don't have a conveyor belt in here. So rather than the conveyor belt moving, what can you do? You can move. Okay, so Miss Barney and I were talking, and we decided we were going to take this one step further than what we were doing. All the green are going to work together, all the red are going to work together, and all the white are going to work together. But I need you to listen. You can't be, nobody can be standing around. Okay, you're going to mix your Play-Doh. Okay, and the first thing that everybody wants to do is mix it all into one big ball. And we are going to give you 2 rolling pins. I'm going to give you about 2 minutes to work with your group and come out with the best game plan you can come up with to turn this into an assembly line to mass produce as many usable, interchangeable parts as possible. Remember, to be usable, they have to be the same size and the same thickness. To start with, your Play-Doh needs to be in a ball.
So get your
Okay?
Play-Dohs right here.
Remember, we're going to try to make it over here. It's terrible.
They have smaller shapes.
Wait, here, Garrett. Garrett, you better be ready. What do we have here? A caliper. Grab your caliper. Go ahead and examine yours.
I think those stars are small. You don't squeeze it. This one is exactly.
Roll them so that they're like this, so that when you roll out the Play-Doh, it makes it a longer shape more than a round shape, okay? And then the next person on the assembly line can pick up the shape and bring the finished product to the end. That person can do 2 things. They can also serve as quality. Oh, this one's not very good. We're going to start back over. Okay? So you have 4 or 5 people on one side of your assembly line, each doing a job. Does that make sense? So that nobody is sitting there. Maybe the first 10 seconds, you got people sitting there watching the first person roll, but after they get done rolling and they move to the second one, Zena was then cutting. We moved to the third one, Isabella was starting to pick them up. Okay, get to the 4th one, Kinley was picking up the good ones and deciding whether or not they needed to be scrapped. Okay? And then I have my guys over here that are getting the dough ready for me to continue to roll out. All right? That is what an assembly line should look like. And you guys did a really good job at producing your shapes, but we could have been more efficient with it. Okay? And that's kind of what we're doing with this lesson. We're learning about how to be efficient and how to put forth our best work so that our customer is happy. Okay? We don't want to waste time, we don't want to waste money, we don't want to waste our resources.
When I walked in this class, it was different because you got to learn more about life skills and what you're involved in. I enjoy most learning about things that I didn't know happened in working facilities. This project will help me in my future by knowing the exact measurements and making sure that everything is correct to get the right amount of quality for the project.
I like seeing all the different tools and how they work. It's pretty cool figuring out how tools work. I would like to be an engineer. That's one of the career fields I would really like, and everything I'm learning in this class would really help with engineering.
I know it's going to be 1 point something, so you're going to hear me just say the decimals. You got 209. What'd you get, Ash? 1.304. That is 5 1,000ths of an inch difference. That's pretty accurate. What'd you get on yours? You had 203, 209, and you had what, Ash? 304? That's pretty close. I would like to have more accuracy than that, but given the short amount of time we've done this so far, I hope someone can beat that. Is your table done? What was your measure? No, you. 1.212, what'd you get? 1.224, what'd you get, Leah? 205, so we got 220? 224, you got 225, you got 203, what'd you say? 205, what'd you get? We both got the exact same thing, 205. So the accuracy here, we're about 20 1,000ths or 10 500ths of an inch off. Now that might be okay for, I don't know, parking cars, but it wouldn't be okay at Altec, and it definitely would not be okay at Airbus. We are trying to get more and more accurate, more and more precise. Look, if you guys were building airplanes, okay, and you got 1.205s, you got 1.225, I'm not sure if I'm riding that airplane. See what I mean? Because the measurements are off. Airplanes, if they're not built correctly, they usually don't stay in the sky. Where's my tool managers? Right here. Who is this?
Mr. Bell. Okay. Do we go on the black thing? The black one or the red one?
The pointer, the black. Boys and girls, we talked about this yesterday. It's the third question I've had this period. Which pointer in that dial are we using, the red one or the black one? Red. I think it says in red in the dial millimeters. We do not use metric. I think in the dial it says 0.001 IN, standing for inches, and that's written in black. We use the black pointer or hand, okay? A is the width of this way. Now, according to an ask, don't have up yet. First two numbers are the ruler only in North dial is 1s and 10s. When they're asking for how thick this is, they're talking about the thickness of the wall. Not how thick it is this way. How thick this is that makes the wall. Cam? Measure the wall, this wall. So if you guys have measured front to back, that's just how deep it is. That's not called thickness. You're supposed to measure the width and the height, and not the depth. The last question says, measure the thickness of the plastic bin. How thick is it? How much plastic did they use to build one of those walls? Because if it was me, I'd say, oh, we're using too much, we're spending too much money, I have to make it thinner. That's just me. I'm frugal. You know what that means? I'm cheap.
I enjoy this class because it's very hands-on, and it's a lot different than some other classes we've experienced before. This is getting me better at things like measurement and fractions, which can be useful in the future, especially let's say if I'm cooking or doing something outside that might require me to know how to do these things. It's good to know these skills.
I like most about We Build It Better is that it's just really fun because I get to talk with my friends while also doing schoolwork, so it's a lot less pushy from the teacher, and I can kind of do what I want as I do my lessons. It'll let me know how to measure better, and especially because I'm wanting to become a pilot. It'll help me with the goal, with like knowing how high up in the air I am, my speed, my aerodynamics, and all of that.
In this class, I really enjoy about the fact how everything keeps like moving. We get to move around and do a bunch of stuff with like a bunch of different types of tools. We finally get to learn something that we could be able to use in the future. When I grow up, I am planning to either be some type of animator or designer for movies and stuff, or maybe an architect, somebody that builds and stuff.
We Build It Better helps with like more hands-on experiences and actual stuff that I'll like use in the future, because like I want to become an engineer. It helps me like know my fractions better, and for whenever I'm like wanting to build a house like precisely so I don't mess up. Today I'm learning about like how a little measurement can throw off the entire project, because say something is like supposed to be measured a certain way and then you measure a bit over it, it'll mess it all up and it won't fit properly into where it's supposed to fit.